Okay, I'm going to continue our example from the previous video. I'm going to try and define the angle between two vectors in an inner product space. So we already had an inner product on P2. We had two particular functions, f and g. We found the inner product of f with g. We found the norm of f. When we say the angle between f and g, we mean this formula. The cosine of theta is the inner product of the two functions, or the two vectors, divided by the norm of the two vectors. This is exactly the same formula you should have seen in Calc 3, only a dot product in the numerator. So this should look pretty familiar. It's the angle between two vectors. One thing that's going to be a little tricky or a little weird in this case is that we're used to graphing polynomials in an x and y plane, and then it makes sense that we would be talking about the graph in the x and y plane. That is completely unrelated to what this angle between means. This is very much like a theoretical concept, thinking about it in terms of some basis vectors. What's the angle between them in terms of some basis vectors? This is not going to be anything that we can spot in a normal Cartesian graph of two functions. Okay, anyway, in order to finish this calculation, we need the inner product of f with g, which we know. We need the inner product of f, which we know. We also need the inner product of g itself. So let's write that down real quickly. Inner product of g would be the square root of g with g, which is the square root of the definite integral of x squared plus x times x squared plus x dx. And if you just got done watching the last video, you don't need to watch me do this. The answer I end up getting out of this is 1.0165. Depending on your numbers, you might be able to write your answer as like the square root of 2 or square root of 2 over 2. These particular examples, I just used a calculator and got an approximation. Okay, so we now know the numerator and both parts of the denominator, so I'm good to go to use this formula. And I think I want to find the angle, so I will take an inverse cosine of both sides. So theta is cosine inverse or arc cosine of inner product of f with g divided by norm of f, norm of g. Okay, which is the inverse cosine. Since we already calculated all these numbers, the numerator is negative 1.216 repeating. The denominator is 1.6931 times 1.0165. Okay, I'm going to type that in a calculator. If you leave your calculator in degrees, this should spit out the answer 134.98 degrees. Okay. Something to point out, analogies to when we talked about the same formula for dot products. When the dot product was positive, that means that the two vectors are kind of pointing in the same direction. It has an acute angle between them, and so the angle was smaller than 90. When the dot product is negative, we got an angle that was bigger than 90, an obtuse angle. And this is essentially playing out again. Only, again, we have trouble visualizing what exactly do we mean by the angle between f and g. It's kind of a theoretical concept. All we can say is that f and g don't really have much in common. They're pointing in different directions. Okay, so that's it for this video.